All out. So you missed the first lecture. तो अभी क्या करें? Let's see. इतना समझ में आता है. Where is the red marker? नीचे. नीचे कैसे गिर गया? So where were we? What was I explaining in the last class? Planings?
Planings, right.
Right and good. Okay. Where is the coil? So anybody has pencil? Give me a pencil, long one. No, wooden pencil, long. हाँ ठीक है चल जाएगा. Want to switch it off?
I told him, he told me what is it.
Both are closed. We'll switch on the fan. Okay, so to understand Fleming's right-hand rule, I am making a armature coil. Now this is your coil, okay? So what is the diagram we drew? We had drawn that. What was Fleming's right-hand rule? So what did I explain? The thumb is the direction of motion, right, or force. Then right. So this is the direction of field. This is the direction of induced current. Right, field is magnetic field B, induced current is I. And this is the direction of force or motion. Right? So if you use, this is how to do. Right? So this is F, this is I, this is T. What is D? Index finger. Index or first finger. What is I? Middle or central finger. Okay. What is F? Force. Thumb, which is force or motion. Motion will always take place in force direction. Force or motion. So this is thumb. Okay. So to illustrate, suppose you have magnetic field in this direction. So what should be the magnet here? North and south, correct? Because from north field line will emerge and it will enter into south. Now we are placing this coil like this in this plane. So how will I show? I will show it like this. I told you that this coil is mounted on some axis. Okay, so this pencil is the axis on which this coil is mounted. So how is the field? Field is in this direction. Okay, and coil is mounted, and this coil is being rotated. Okay, what are we doing? The coil is rotated. So if I have some blades fixed here, right, and I make the damp water to fall on it, then this coil will continuously rotate in the magnetic field. Correct? Now see, when the plane of the coil is like this, plane, right? Is any field line cutting it? Field line is going above and below. Is anything cutting it? So, is there any flux linked with the coil? No. Right? What is flux? I told you, right? So now if the coil is rotated like this, now will some line pass through the coil? Yeah. So let us say there were 4 lines. So now 2 will pass, still the first and second is missing. Now if it is in this position, all 4 are passing. So you can see whenever the coil is rotating, the flux linked with the coil is continuously changing. So no flux to maximum flux to again minimum flux to maximum flux. So as long as the coil rotates, the flux is continuously changing through the coil. Then what was Faraday's law? Whenever the flux will change, current will induce in it. So now how the current will induce? Now see, what is the direction of current in the coil? And for that, so coil has 2 edges, right? So let me name this as A, B, C, D. A, B, C and D, right? Then what I will do is, I will connect a ring over here. Let me draw it with different colors. I will connect a ring over here, right? And this wire, I will connect another ring. There is another ring. So center of the ring is on the axis only. Okay, it is fixed. This ring is centered around the axis. And it is fixed to the coil here. It is fixed here. So this wire is passing through this ring. There are 2 rings. Now what we are doing is, we are providing connection. One connection over here, one connection over here. Okay, and there is a resistance. Okay. I will take the potential difference from here. This is where the voltage will develop. So what happens is, now see, how is the coil rotating? If the water is falling here, it will rotate anti-clockwise. Okay. So what is the motion of AB? Downwards. What is its motion? Upward. Right? What is the magnetic field direction here? In this direction. What is the magnetic field direction? In this direction, right? This is the direction of field. So current, you have to align your finger. So now see, this is left hand. Which hand we have to use? Right. Okay. So field is in this side. Okay. Where is the motion? Down. So where will be current direction? Outward, like B to A. Got it? See, this is the field, and how is the motion? Down. Rotate around the axis, field axis. Very easy. Okay? So where is this central finger coming? Out. So how is this coil? Coil is like this. It's shown in the page like this, but it is this. So where is the field now? So on the left side, this is AB. This part is AB, right? So where is the field? Like this. And where is the motion? Down. So where is the current? B to A. Got it? So what is the direction of current? B to A. So it will come out. So current will come out. Right? And at the same time, when this is going up, B, so current is going in here. So this is perfect. Okay? Meaning the current is in this situation right now. Okay? Now when the coil turns 180 degree, now look here. Now what is happening? This copper, this is different, right? Initially it was like this. The copper was on the right side. Okay? Now when it makes 180 degree rotation, then what is happening? CD will come this side and BC will go here. Anna? So now what is the direction? CD is going down and AB is going up. Correct? So now the current direction will reverse. Okay? So what kind of current you are getting? Suppose initially the current was like this. Now the current is like this. So it is changing direction. Got it? Okay? Current is changing its. So initially the current went like this. Now when CD comes here and BA goes here. Now what is the direction? The direction becomes like this, ulta. Okay? Now the current will change the direction. Is it clear? Every time the current direction will change now. See, initially A to B the current flow was there. Now it will be. Now initially it was B to A. Now when it goes here, then it is A to B. Okay? Right now? So then the direction will change actually. That is why you are getting alternating current. But this is not in the syllabus. I used it only to explain the right hand rule. Where is the direction of induced current? Is that clear? This is AC generator, but it is not for exam. AC generator. But the right hand flaming rule is explained here. Okay? If I don't discuss this, you will not understand how this flaming right hand rule is applied. Okay? So is this thing clear? Just switch on the fan. First. ठीक है चलो. Okay. So many questions. We covered electromagnetic induction in the first class. Then we covered Faraday's law, Lenge's law, and Fleming's right hand rule. Okay, Fleming's right hand rule is also covered, right? So any questions here? And then I also have showed you AC generator, but this is not required. Till here you have got this. Its application I showed you. Okay. Then next is difference between AC and DC. Okay. Next is difference between AC and DC. Any questions till here? So we are getting a cycle now, right? So in our home, what do we get? Our home, the voltage we get is AC voltage we get is 220 volt. Okay, and what is the frequency of it? Frequency is 50 hertz. So in 1 second it changes 50 times. ठीक है ना? हमारे घर में जो voltage आता है, like between these two, okay, it is this voltage, 220 volt AC, and it changes 50 times in 1 second. That is why its frequency is 50 hertz. Got it? Now, next part is difference between DC and AC. So first, what is DC? AC? Alternating current, right? So DC and AC. First difference is its magnitude. Direct current does not change with time. With time. That is, it remains constant. What about AC? AC current? Its magnitude continuously changes with time. Right? So if I have to draw the graph of DC current with time, its graph will be straight line. It has a constant value. Whereas for AC, the graph will be something like this. So AC, the current is small I. So it will be continuously changing. Right? So you get cycles with time. Okay, so it is continuously changing. This is the first difference. Second is its polarity remains same. Remains same. Right? Here, for some time it is positive, for some time it is negative. So its polarity changes periodically. After every fixed time, its polarity will change. Right? So 50 in 1 second, 50 times it will be positive, 50 times it will be negative. So its polarity changes from positive to negative periodically. Right? That is 50 times positively and 50 times negatively in 1 second. ठीक है? तो 1 सेकंड में कितनी बार चेंज होता है? 100 पॉजिटिव नेगेटिव 50 बार पॉजिटिव होता है, 50 बार नेगेटिव. ठीक है? So what is its source? कहाँ से मिलता है DC current? What supplies DC current? Yes, cells. So its source is cell or battery. ठीक है? इसका सोर्स क्या है? Its source is AC generator और mains. जो अपने घर में आता है उसको mains बोलते हैं. AC generator जो मैंने यहाँ बनाया, कैसे करंट बनता है वो भी बताया मैंने. और ठीक है, तो ये जो इलेक्ट्रिसिटी है वो कैसे बनाई हमने? आइडियल इलेक्ट्रिसिटी. डैम का पानी गिरते रहेगा, तो कॉइल चलते रहेगा, करंट आता रहेगा. समझ आ गया? अगर डैम का पानी नहीं है तो क्या करेंगे? विल बर्न वाटर. हाँ, स्टीम बनाएंगे. वो स्टीम को इधर गाइड करेंगे. स्टीम में इतना प्रेशर होता है वो उसको चलाएगा. दैट इज थर्मल इलेक्ट्रिसिटी. तो उसके लिए अपने को कोयला जलाना पड़ेगा, है ना? दैट इज ऑल थर्मल इलेक्ट्रिसिटी. तो इलेक्ट्रिसिटी का नाम कैसे पड़ता है कि हम कैसे इस कॉइल को चला रहे हैं. जनरेटर सब में सेम होता है, खाली हाउ द कॉइल इज रोटेटेड. न्यूक्लियर एनर्जी क्या होता है? वी कैरी आउट न्यूक्लियर रिएक्शन. उसमें बहुत हीट जनरेट होता है. वो हीट से वाटर गर्म करेंगे, उससे स्टीम बनाएंगे, वो स्टीम से कॉइल चलाएंगे. अल्टीमेटली हमको सबसे मिलता है क्या? इलेक्ट्रिसिटी. ठीक है, समझ आ गया? हाँ, तो ये जो है ना, दैट इज, इसमें यही है, दैट इज इट फ्लोज इन वन डायरेक्शन. हमारे बुक में वन डायरेक्शन दिया, ठीक है. और ये क्या होगा? इट्स डायरेक्शन चेंजेस. पोलैरिटी मतलब डायरेक्शन है. डायरेक्शन चेंजेस पीरियडिकली. और इट्स direction changes periodically. Both mean one and the same thing. So what are the advantages of AC over DC? And with that, this chapter will be over, because transformer is not in the syllabus, right? Is it in the syllabus? It's not in the syllabus. Have we downloaded physics syllabus?
Transformer is not. Transformer is not.
ये क्या है? स्पेसिमेन भी आ गया तुम लोग का? सिलेबस ये क्या है? एजुकॉर्ड.
Yes, sir.
Can all of you see it?
Yes.
So this is electricity and magnetism. So we covered all of it. Magnetic effect of current we have already covered. Principles only, statement of laws. So statement not required, but we have done that also. Electromagnetic induction, that also we have done, right? So we have covered overstate experiment. Field lines, we have covered overstate, right? पहला वाला कंपास किधर डिफ्लेक्ट होता है वो. Then right hand thumb rule, okay? Then we did magnetic field due to a current in a loop. Right hand thumb rule वो अलग था. First unit A. Then electromagnets, their uses, comparison. We have done that. We have done that, right? Electromagnet use. Then comparison with permanent magnet, similar, right? Coil का field और permanent magnet का field similar है. Conductor carrying current in a magnetic field experiences force, आज किया. Fleming left hand rule, आज किया. And its understanding, right? Simple introduction to electromagnetic induction here in the first lecture today. Then a magnet moved along the axis of solenoid induces current. वो भी बताया, ठीक है? Fleming right hand rule अभी किया हमने. And its application in understanding the direction of current in a coil. Direction of current जो induce होता है, वो कैसे होता है हमने Lenge's law सीखा. And right hand rule भी सीखा. तो दो रूल है जो इंड्यूस करंट का डायरेक्शन देते हैं. क्या क्या? लेंस एंड लेंस. समझ आ गया? So those who are absent थोड़ा स्ट्रगल हो सकता है. So look in the video, lecture video. Then we did comparison. है ना?
सर बंद हो गया था.
नहीं फिर से चालू किया था ना. अच्छा फिर बंद हो गया था क्या? तुम लोग तो प्रिविलेज्ड हो गए फिर जिसने अटेंड किया. जिसने अटेंड किया उसको पूछो, नहीं तो एक्स्ट्रा लेक्चर. ठीक है? तो ये चैप्टर हमारा खत्म होता है. ठीक है? सो और इसमें न्यूमेरिकल नहीं है. ठीक है? तो हीट स्टार्ट करते हैं, है ना? नहीं? किसी को कोई डाउट है? 5 मिनट्स आई विल क्लियर द डाउट्स. ये वाला एक्चुअली ये है नहीं सिलेबस में. तुम ये समझ लो क्या कहते हैं इसको कि इंड्यूस करंट का डायरेक्शन कैसे निकलता है. ठीक है? देखो समझो ये तुम्हारा इलेक्ट्रिक कंडक्टर है या कॉइल है जिसको मैं मैग्नेटिक फील्ड में घुमा रहा हूं. ठीक है? मैग्नेटिक फील्ड कहां से कैसे है? लेफ्ट से राइट जा रही है. मीनिंग दिस इज नॉर्थ पोल एंड दिस इज साउथ पोल. तो ऐसे जा रहा है. अब ये कॉइल कैसे मूव कर रहा है? समझो ऐसे मूव कर रहा है ना? ये कैसे मूव कर रहा है? ऐसे. फील्ड कैसे आ रहा है? ऐसे. तो अगर मेरे को राइट हैंड रूल लगाना है तो कैसे लगाऊंगा? ये जो है फील्ड का डायरेक्शन है, वो तो ऐसे ही है. ठीक है? मूव कैसे कर रहा है? ये नीचे. तो ये मेरे को क्या करना पड़ेगा? इस पॉइंट पे फील्ड का डायरेक्शन चेंज नहीं हो रहा है, खाली क्या डायरेक्शन चेंज हो रहा है? मोशन. मोशन किधर? अंगूठे के डायरेक्शन में, नीचे. करंट किधर है? ऐसे. तो इधर ये साइड में करंट किधर आएगा? ऐसा आएगा. और ये किधर जा रहा है? ऊपर. तो यहाँ पे कैसे बनेगा? ऐसे. मोशन ऊपर है ना? मोशन ऊपर, फील्ड ऐसे, करंट किधर आ रहा है? ऐसे. तो हमको बराबर करंट ऐसे मिल रहा है. ठीक है? अब तो यहां से यहाँ ऐसे करंट जा रहा था. अब जब ये घूम के ऐसे आ गया, अब यहाँ पे क्या हो रहा है? ये तो फिर नीचे जा रहा है. तो इसमें पहला करंट ऐसे आ रहा था. अब जब ये यहाँ पे आया तब क्या होगा? ऐसे जाएगा, है ना? यानी आफ्टर एवरी 180 डिग्री क्या हो रहा है? करंट का डायरेक्शन चेंज हो रहा है. समझ आया? और कुछ किसी को समझना है? लेकिन ये है नहीं, ये सब है नहीं, खाली ये समझने के लिए मैंने बताया. सोलिनॉइड में कैसे चेंज होगा वो समझ लो. समझो अभी तुम्हारे पास सोलिनॉइड है. अब ये सोलिनॉइड है, देखो इधर. ये जो सोलिनॉइड के पास में मैग्नेट लेकर आएंगे तो क्या होगा? ये क्या है? गैल्वेनोमीटर है। ये पहला वाला, ठीक है, इलेक्ट्रोमैग्नेटिक इंडक्शन का। कुछ बच्चे एब्सेंट थे, ये इंपॉर्टेंट है। इलेक्ट्रोमैग्नेटिक इंडक्शन समझा रहा हूं। इलेक्ट्रोमैग्नेटिक इंडक्शन ये क्या है? व्हाट इज इट? सोलिनॉइड और कॉइल, इसको कुछ भी बोल सकते हैं, कॉइल और सोलिनॉइड। होता है मास्क आने के बाद बहुत कुछ बदल गया लाइफ में। सो कॉइल और सोलिनॉइड। कभी भी छींक भी आती है ना तो उसको रोकने का नहीं, इट्स अ रिलीज मैकेनिज्म, ठीक है। बहुत लोग सिविल बनने के चक्कर में तो यू विल एंड अप डैमेजिंग योर ऑर्गन्स, ओके, वो नहीं करना है, ठीक है। छींक आवे, पाद आवे, कर डालो, रुकने का नहीं। डोंट बी सिविल इन दीज मैटर्स। लाइफ इज मच, क्या क्यों हंस रहे? अगर मैं यहाँ पे नहीं बोलता तो घर पे जाके नहीं करता क्या? करेगा ना। तो ये सब चीजों में सिविल बनने की जरूरत नहीं है, ठीक है। we are better off not being English in few things. करके सब गंदा ही रहते हो। Okay. I was too blunt. What was I explaining? अभी देखो, इधर से ये मैग्नेट है, ठीक है। Now let us say this was north and south. All right. इस मैग्नेट को हम लोग we are bringing it close to solenoid. Then what will happen? This magnet will have magnetic field, right? So वो चालू हो गया जैसे, पता नहीं क्या होगा। Okay. अब देखो, जब ये मैग्नेट दूर है तब क्या होगा? तब इसकी कितनी फील्ड लाइन क्रॉस हो रही है इसमें से? एक ही जाएगी, है ना, जब मैग्नेट दूर है। लेकिन जैसे जैसे मैग्नेट पास आएगा तब क्या होगा? मोर एंड मोर लाइन विल क्रॉस। तो दिस इज कॉल्ड फ्लक्स। ये जो लाइन है ना, इसी को क्या बोलते हैं? फ्लक्स, ठीक है, मैग्नेटिक फ्लक्स। ठीक, अभी ये तो खाली हमने गिन के वी हैव मेड 5 लाइंस, देयर आर सो मेनी, ओके। तो अभी if you bring this magnet close, then the flux link to the coil is changing. And whenever the flux link with the coil changes, current will be induced in it. पैदा हो जाएगा, current पैदा हो जाएगा, ठीक है। So that is electromagnetic induction. This is the law. Whenever the flux link with the coil changes, current will be generated, produce हो जाएगा। उसको क्या बोलते हैं? Induced. Okay. Now, तो ये क्या हमारा? ये गैल्वेनोमीटर है। गैल्वेनोमीटर का क्या काम होता है? It will detect the presence of current. And it will also give the direction, ठीक है। So when the galvanometer is like this, so at this moment no current in the circuit, ठीक है। Now it is observed when the magnet is brought closer, then it shows deflection. अभी इसमें सेल लगा है क्या? बगैर सेल के करंट आ गया इसमें। कब आया? When the magnet is moved. तो वो करंट का डायरेक्शन क्या होगा? तो जो पहला पार्ट है कि ये डिफ्लेक्ट हो रहा है, दैट इज गिवन बाय फैराडेज लॉ। फैराडेज लॉ क्या है कि ईएमएफ इज प्रोपोर्शनल टू रेट ऑफ चेंज ऑफ मैग्नेटिक फ्लक्स, चेंज ऑफ मैग्नेटिक फ्लक्स, ठीक है ना। ईएमएफ इज प्रोपोर्शनल टू रेट ऑफ चेंज ऑफ मैग्नेटिक फ्लक्स। करंट तो आ गया, लेकिन अब वो करंट कौन सी डायरेक्शन में आएगा? इधर से इधर जाएगा या उधर से इधर जाएगा? तो अब देखो, मैं ना अलग अलग कलर से उसका डायरेक्शन बना रहा हूं। समझो, ये इधर से इधर जा रहा है, ठीक है। तो रूल क्या है? डायरेक्शन का रूल हमको देता है लेंजेस लॉ। ये क्या बोलता है? It's those who attended Lenge's law. What is it? What will be the direction of induced current? The current will be set up in such a way such that it opposes the cause which is causing it. ठीक है, मतलब क्या, अभी जब हम मैग्नेट को इधर लेके आ रहे हैं तो इसकी मैग्नेटिक फील्ड बढ़ रही है कि कम हो रही है? फ्लक्स बढ़ रही है ना, तो इसमें ऐसा करंट बनेगा तो उल्टा मैग्नेटिक फ्लक्स जनरेट करेगा, ये डायरेक्शन। गॉट इट? तो इसको कैंसिल करेगा, तो ये ऐसा फील्ड आ रहा है, मतलब इधर क्या डेवलप होना चाहिए? नॉर्थ पोल, क्योंकि फील्ड लाइन बाहर आ रही है। इधर नॉर्थ पोल डेवलप होने के लिए करंट कैसा होना चाहिए? एंटी क्लॉकवाइज, है ना? तो इसमें करंट कैसा बनेगा? ऐसा बनेगा, तभी तो एंटी क्लॉकवाइज होगा। तो ये अभी किधर डिफ्लेक्ट होगा? ऐसा। जब मैंने तुम लोग को बताया था तभी हमारा ये किधर नॉर्थ डेवलप हुआ था, लेकिन एक डिफ्लेक्ट कैसा होगा? ऐसा। क्यों? वाइंडिंग अलग थी, तुम्हारे केस में यहां से वायर नीचे लिया था मैंने। समझ आया? समझ आया ना? इसलिए तुम लोग कंफ्यूज मत हो जो पहले बैठे थे, तो अभी मैंने वाइंडिंग ऊपर से ले ली। सो एवरीथिंग, मतलब इसलिए ये एक अलग एग्जांपल है, ठीक है? सो अब तुम एक्सपर्ट हो जाओगे अगर तुमने पहले वाला भी किया है। तो अब इसमें क्या हो रहा है? When the magnet is coming closer, here also north pole will develop so that it will oppose, and you are working against this opposition. So your mechanical energy is getting converted into electrical. समझ आया? अगर तुम ये मैग्नेट स्टॉप हो गया तो ये भी जीरो हो जाएगा, सीधा आ जाएगा। ठीक? अब तुमने क्या करा? Now when you are taking the magnet back, अब क्या होना चाहिए? The current will be set up here in such a way so that it opposes the going back of the magnet. मतलब इसको साउथ पोल बन जाना चाहिए। अगर ये रेड होता है ना तभी क्या बन जाएगा? साउथ पोल। That means इसकी फील्ड लाइन इसी डायरेक्शन में, क्योंकि अब क्या हो रहा है? जब ये पीछे जा रहा है तो this flux link with the coil is reducing. So current will be set up in such a way that flux increases in the same direction. So it has to be south pole. Then to take away the magnet also will be a work we will have to do. So unless you are moving the magnet with respect to the coil, you will not see the current lead. So now for south pole, what should be the current direction? Clockwise. So it will be showing clockwise. Understood? है ना? तो करंट हमको तभी दिखेगा जब ये मैग्नेट मूव हो रहा है विद रिस्पेक्ट टू दिस, मतलब फ्लक्स चेंज हो। अगर मैग्नेट रुक गया तो ये भी जीरो हो जाएगा सीधा। ठीक है? This is the only thing to be understood in this chapter: the induced current and its direction. And it is given by Faraday's law gives the magnitude of the current, Lenz's law will give the direction. ठीक है? और दूसरा डायरेक्शन किससे मिलता है अपने को? Yes, Lenz's law and Fleming's right hand rule. इससे हमको डायरेक्शन मिलता है, ये दोनों give direction of induced current. ये बहुत सारे टीचर लोग का भी फंडा क्लियर नहीं है, तुम्हारे स्कूल का तो मुझे नहीं पता, ठीक है? तो इसलिए बहुत ध्यान से समझ लेना, मैंने जितना सिंपल हो सकता है उतना सिंपल करके बताया। स्पेशली घर में कोई भी अगर स्ट्रगल हो रहा है बुक से पढ़ने में, एक लूप बनाओ, ठीक है? मैग्नेटिक फील्ड इमेजिन करो, नहीं तो स्ट्रॉज ले लो, स्ट्रॉज, ठीक है? वैसे करके थर्मोकोल के 2 ब्लॉक रखो, नॉर्थ साउथ स्ट्रॉज बना डालो, उसका मॉडल बना के करो, फट से हो जाएगा। Have one wire, बहुत इजी है समझने के लिए, ठीक है? और बाकी कोई दिक्कत हो तो मैं हूँ, फील फ्री टू आस्क। अगर पूछोगे तो ही आंसर मिलेगा, और पूछने में शर्माना नहीं, मेरे साथ तो बिल्कुल नहीं शर्माना, ठीक है? ये सर क्या सोचेंगे और ये है वो सब बिल्कुल नहीं सोचना है। कहीं पे भी स्ट्रगल है तो पूछ लो, लोग हंसेंगे, हंसने दो। चलो नेक्स्ट इज, सो दिस चैप्टर इज ओवर, राइट? What will you do if you are in a lift? Huh? You will sneeze, right? You will sneeze in the lift. And what if you had the other arch? What will you do? Depends. If it is just couple of floors, you can hold it. Otherwise, it is not your responsibility. So everywhere there is a ventilation system, okay, which takes care of. So not the, I can't promise the same here. This is not ventilated, right? Okay. Calorimetry. So next chapter, we have how much time? We still have 15 minutes. So that is sufficient for good introduction. So this is chapter number 11. Wow. So calorie is energy, heat energy, metry, measurement of heat. What is calorimetry? Measurement of heat. So it means measurement of heat. Okay, so calorimetry deals with the science of measurement of heat. Okay. Now next. So in 9th standard, have you studied about heat?
Yes.
Okay. So let us understand what is heat and what is temperature. Heat and temperature. Are they both same? Who will answer? Is heat and temperature same? No. What's the difference?
Heat is degree of hotness and
Yeah, go ahead.
temperature is
Yeah, anybody else? Actually, it's the other way around. Temperature is degree of hotness. It's a sensation, right? Temperature is degree of hotness or coldness. So it's a attribute. Whereas what is heat?
I was speaking difference between coldness and
Heat is energy. What is heat? Energy. Temperature is not energy. It is sensation, right? So what temperature difference? First of all, they are both different because what is unit of heat? Joule. What is heat unit? Joule. What is temperature unit? Celsius, Fahrenheit, or Kelvin, right? What is the SI unit in this? Kelvin. Okay. So Joule or Kelvin. Then heat has other units also, like calorie. Okay. And relation between calorie and joule is 1 calorie is 4.2 joule approximate. 1 calorie is 4.2 joule. And 1 joule is 0.24 calorie. Okay, this is the relation. So what is temperature and what is heat? So heat is the measure of internal energy of the constituent molecules, constituent atoms or molecules of the body or substance. So if you have any hot substance, right, whatever is its internal energy, that is its heat energy. Where the internal energy comes from? It is the atoms, right, which are constantly vibrating. Okay, so it will have kinetic energy. Now, not only vibrating, they are also like in a spring action, right? No two atoms are getting merged into one another, right? They are at some equilibrium distance. So it's like if you stretch a block, then it has potential energy, right? So they are lying in an equilibrium state. So every atom is stretched in some equilibrium state. So they have potential energy as well as kinetic energy. That is internal energy. Okay. So what is the internal energy? That is kinetic plus potential energy of the quantity. Is it understood? Okay. Now what is temperature? Temperature is the degree of hotness or coldness of the body, of the substance or body, whatever. So why is temperature important? So temperature decides the direction of flow of heat energy when two bodies at different temperature are placed in contact. Right? So suppose you have two bodies A and B. So A is at temperature T1, B is at temperature T2. So if T1 is greater than T2, then in what direction heat will flow? In this direction. Okay. What is Q? Heat energy. Then heat energy will flow. Heat energy Q will flow from body A to body B. Right? Understood? What determines the flow of heat? Temperature. Like what determines the flow of current in electricity? Potential difference. Potential difference. So higher potential to lower potential. Likewise, heat will flow from higher temperature to lower temperature body. Okay? That is, heat flows from body at higher temperature to body at lower temperature. ठीक है, समझ आ गया? Next is, suppose I have a body at a higher temperature. Does it mean that it will have more heat energy than the body at lower temperature? है ना? How many of you agree with him? Any body which is at higher temperature will have more heat energy than lower temperature. How many of you agree with him? Raise your hands. Some of you don't agree. Oh, all of them agree. Right? All of you are wrong. Okay? If you have a cup, a nail, or a cup of tea, right? It is hot. You are holding it, right? Where will be the heat flow? When you are holding a hot cup, obviously the heat is flowing from the cup to your body, because body temperature is less than the tea temperature, right? So, but still the heat is flowing from body or substance which is having less energy. How much calorie a tea will have? 10-20 calorie or 10 calorie? How much calories we have already? Thousands. सवेरे से 3 बार तो खाया, कितना खा के आया तुम? एक बार खाते हो तो एटलीस्ट 1000-1500 कैलोरीज तो अंदर जाता है. टी में कितना है? 10-20. Still heat is coming from tea to you. Understand? So it's like, because of temperature difference, the energy direction is decided by difference in the temperature, not by amount of energy. So in this case also, this is a smaller body, right? So if T2 was greater than T1, then the heat will flow from B to A. It does not matter who has more energy or who has less energy. Is it clear? So more temperature does not always mean that it has more energy, right? Is it understood now? So like in case of water, right? So you have a sea, right? Sea water. And you have a water in a mug. Which water will fall here? Water in the mug into sea, or sea water will rise into mug? Water in mug will fall. So the amount of water does not matter. What matters is level. So temperature is at level for heat. So if heat is always transferred from body at higher temperature to body at lower temperature, the amount of energies in them does not matter. समझ आ गया? Like potential difference होता है इलेक्ट्रिसिटी में, लेवल होता है मैकेनिक्स में, हीट में क्या होता है? टेम्परेचर. वो जो डिफरेंस है वो क्या है? टेम्परेचर. सो फिजिक्स में देयर आर पैरेलल्स. Different branches have similar logic. Okay? So if you understand one branch well, like mechanics, you'll also understand electricity well. You'll also understand heat well. So heat अभी एक नया branch है. ठीक है? समझ आ गया? All right. Now, so heat energy depends on the internal energy. What does the temperature depends on? It only depends on the kinetic energy. खाली जो मूव करता है, ठीक है ना? तो एक पार्टिकल भी अगर अच्छे से ज्यादा मूव कर रहा है तो उसका टेम्परेचर ज्यादा होगा, तो उस पर डिपेंड है. So temperature depends temperature of the body only depends on the kinetic energy of its constituent particles. Hope you are understanding it. Heat energy is a measure of internal energy, so which has kinetic as well as potential. Whereas temperature only depends on the kinetic energy of its constituent particles. Okay. So I think this was the introduction to calorimetry. Temperature is measured by thermometer. Okay. Heat is measured by calorimetry. That we'll learn. Okay. So it is little indirect. Whose pencil is this? Yours, right? Okay. See you in the next class.